Next up, we have Tara Slough, who is an assistant professor in political science at NYU. And yeah, she'll be talking about external validity and meta-analysis.
Okay.
Tara, take it away.
Thank you so much. Let me set a timer. Otherwise, I will certainly go over.
Okay.
Thanks so much for having me. Thanks all for coming. This is joint work with Scott Tyson from Rochester. So I got started thinking about this actually doing some meta-analyses. So I worked on 2 projects in EGAP's Meta-Cata initiative, and these are sort of coordinated and harmonized field experiments that are designed with the goal of ultimate synthesis through meta-analysis. So I worked on 2 of these 3. There's now 4 that are complete. And sort of the stated goals of this project are accumulation and to address the crisis of external validity for experimental social science. And so as I worked on these, I wondered sort of how tightly our design was actually connected to these goals, and if we could articulate a little bit more precisely what we were doing here. And so this is an effort to try to answer those questions. And so I see sort of a fundamental challenge of meta studies or meta-analyses in that when we do sort of 2 experiments on the same phenomenon in different settings, we're always going to end up with different estimates of the treatment effects, right? And there's 3 different reasons why this could be the case. And ultimately, it's going to be very difficult to understand where sort of differences are coming from. So first, we could have statistical noise. So coming from things like sampling variability, the random assignment of treatment, or measurement error, those things. But I think 2 other possible explanations are that we have just fundamental differences in the experiment, right? We're not looking at similar enough outcome measures, or our treatments are too different. And the third one is that sort of the underlying phenomenon or mechanism we're trying to study is not generalizable. It's producing different effects in different places. Right. And so the challenge here is that noise is always going to be present, and this is going to limit our ability to sort of think through number 2 and number 3 with any sort of given data that we have. And there's sort of been a lot of advances in this panel and in this audience on sort of estimation in meta-analyses. And that's largely, I would argue, related to number 1. And this is like really great, important work. Our focus here is going to be more to try to think through number 2 and number 3. Okay. So what we're going to try to do is have a conceptual framework for meta studies. So we can think about these each as an experiment, and we want to think about what properties we would want within study and then across studies in order to make sure that we are producing comparable estimates. And we're going to try to separate this into 2 features, right? The first is going to be design choices by researchers, so things that we make when we go and put an experiment or study into the field, and also assumptions both that we should be maintaining within the study and across the constituent studies. Okay. And so first, I want to think about what external validity is and sort of think about how it's been conceived. We'll be providing sort of a formal definition. And I want to note that this is, not uncontested, we'll say. So there's sort of many views as to what external validity is when you read the literature across disciplines in philosophy of science elsewhere. And we've sort of classified these existing accounts into 2 types, projective, as we're calling them now, and deductive. And so projective concepts sort of view external validity as potentially a property of a single study or estimate that we're trying to project onto some other type of population or some difference in experimental conditions. And also deductive concepts, which is sort of where we're going to be focused. And for us, this deductive approach views external validity as a relational property between a set or cross-section of studies. So just very quickly, why these 2 things are different and where we're starting from. So these projective concepts of external validity, I think of in this way, right? We have one study and we're trying to say something about what we've learned from this study and take it elsewhere. And so here we might think of external validity as a property of that study or estimate. And so a lot of the work on sort of thinking about extrapolation of estimates to different settings, samples, or outcomes or treatments sort of fits in this category, ideas about the transportability of estimates, and also the discussions of moving from sample to population estimates. So moving from state to PATE, comparing the two, thinking about the difference between the two of these. I would say that these three are really heavily focused on estimation. This last parallelism is perhaps more common in philosophy of science and sort of thinking about how findings travel from across research designs or settings, right? Specifically lab to field. We are instead going to be thinking about external validity deductively. So thinking about how these study the sort of underlying relationship between the causal mechanisms across these studies. So we'll be thinking about this as a relational property. And we haven't found sort of formal definitions of this in the literature, though there's some good work making this argument. And we think that meta-study practitioners, including people doing meta-analyses, seem to be invoking sort of this deductive concept of external validity. And I guess the sort of where we take this is just from our behavior or our choices, right? If this were not the case, why would we not just spend the money or time? Why would we just not devote all our money to a single study? When we choose to do this in multiple places, these studies in multiple places, it comes at a big cost to power. And so like by making that investment, it seems that this is sort of what is underlying those choices. So I want to sort of walk you through our framework and main results. So first, we want to think about the properties of individual studies. And so for us, we're going to, the objective of a study here is going to be to measure the causal effect of a mechanism wherever it may be present. And then we'll move from studies to meta-analysis, where we're going to combine the findings from multiple studies that pertain to the same mechanism in multiple contexts or samples. So for us, individual studies are going to be characterized by three things. The first element is going to be the setting. We'll think about indexing by this theta in the set big theta, where big theta is going to represent the settings wherever a mechanism could be operative. So in my field, political science, people often sort of refer to this as the scope conditions or a theory or argument. So where should we expect this mechanism to present? The second piece is going to be the set of measurement strategies. And we can think about these just as a set of outcome measures that when we estimate some type of treatment effect might be able to reveal the presence of an underlying mechanism. Okay. And the third piece is going to be a contrast. And we can think about this as sort of the set of instruments when we, and that we will be sort of looking at the difference between. And so we can think about this omega prime as control, omega prime prime as treatment. And so this is sort of just with it sort of baked into any experimental setup. So given these three pieces, we can then define a study as the triple that's defined by the measurement strategies, contrasts, and settings. And then a meta study is simply a collection of studies, right? So each sort of our goal in each study here, these are sort of causal studies, is that each study estimand is going to be some treatment effect, right? And we will assume that the treatment effect is a smooth mapping of measures, contrasts, and settings onto the reals. We will assume that the derivative of our treatment effect has full rank for almost all contrasts. This is not particularly restrictive in this setting. So we can think about our relationship to the potential outcomes framework, that when we talk about a treatment effect, we are sort of looking at, you're sort of evaluating either sort of the expectation or the quantile of, the treated potential outcomes on some subset of, units in treatment minus, the control potential outcomes on some set of units assigned to control. Okay, so that's sort of the basic setup for a study. Or the example that we've been using, but I think will need to be moved shortly, is sort of from Lind. This is a treatise on the scurvy. So this is one of the first medical experiments, which is in Don Green et al.'s textbook. And he gave us this idea as sort of something with a really clear idea of how we might think of a mechanism. And since that's central to our framework, we'll be thinking about it here. So this was an early experiment on ships in the 1700s in which Lind was trying to figure out how to treat scurvy. And this is noted for the clarity of the mechanism, vitamin C, right? So we can think about the treatment group as giving these seamen citrus, which increases vitamin C absorption, which then reduces scurvy symptoms. So we'll think about how this maps onto the study. So when we think about this study, sort of the setting here is like the ship or the characteristics of the ship upon which the experiment was conducted. The contrast, right? This is an experiment, so we have a treatment and a control. So we can think about his experiment was a little bit more complicated, but we can think about two arms, sort of this lemons and oranges versus pure control or do nothing, right? And then the measurement strategy, we might think of an outcome measure closest to what he describes as being an indicator for the incidence of any scurvy symptom, right? And so in sort of the study, this experiment was conditioned on sort of the subjects having scurvy symptoms, right? They were already sick. And so we might expect the treatment to work on all participants. And so we define sort of the subset of units where we might expect the mechanism to present as all units. If we care about averages, we could well take the average treatment effect. So we're going to add one additional assumption to individual studies, which is not standard in sort of the design-based experiments. And this is not going to really mean anything important for an individual studies, but it's going to be important when we sort of try to combine studies, and that is divergent validity. And what divergent validity means here is that this is a property of a measurement strategy, so an outcome measure. And the idea here is simply that our treatment effect on one outcome measure is different than the treatment effect that's present on any other outcome measure that is different, right? And so concretely, we would say that in this Lind study, if divergent validity holds, we should expect different treatment effects if we use different measurement strategies. So the main one I had said is any scurvy symptom, right? So this is like an indicator for the union of any of the sort of 6 symptoms of scurvy, bloody gums being only one. So the idea here is we would expect different treatment effects on these two things. All right. So the framework here then is how do we then combine the studies? How do we make these links across the studies? And so we're going to say here that the goal is what we'll call comparability. And we're going to say that 2 different studies, right, which could have different measurement strategies, different contrasts or treatment and control instruments in different settings, are going to be comparable if they produce the same treatment effect, right, up to noise, right? And we'll say that the meta study or meta-analysis has constituent comparability if all of the studies are comparable. And right, this is sort of really sort of pretty intuitive to think about. And we'll think that 2 studies are comparable when they allow us to make apples to apples comparisons, right? And so ultimately comparability is going to involve 2 things, right? It's going to involve our design decisions, how we design our experiments, and we'll think about these in terms of harmonization, which is a word used in the meta-ketas and elsewhere. And we're also going to say that it involves assumptions about the manifestation of a mechanism as a treatment effect. And this is going to be about external validity. So first, let's think about these design aspects or harmonization. So we can think about 2 studies as being contrast harmonized if the instruments are identical in both of the experiments, right? So both control and treatment. And so this is sort of one thing that I came to in sort of analyzing and thinking about these meta-ketas. So all of the meta-ketas have an arguably harmonized treatment that people spent hours and hours trying to hash out, but they all sort of use status quo controls. And when we go across contexts, you know, the status quo may be very, very different in different places. And ultimately, since we're trying to identify, you know, the treatment effect as a difference, right? Those contrasts are pretty variable across the studies. Second, we can think about measurement harmonization, which I think is more straightforward to think through, that we want to be using the same outcome measures for almost every contrast and at almost every setting. Here, this is pretty concrete to think through. I think there's a lot of things we still don't know about when measures are harmonized in different settings. And sort of it's a much more fundamental issue than sort of current treatments that basically just try to rescale or normalize outcomes across sites. But we will leave that here for now. We will say that a meta study is harmonized if every constituent study is both contrast and measurement harmonized. So in terms of harmonization, these design decisions, right, we might think that sort of two experiments, experiment 1 and experiment 2, are not harmonized here. This one compares the lime or the lemon and orange to nothing, right, like Lynn did. This one, the treatment is lime and orange versus nothing. And so the lime and orange is sort of a different treatment, because limes have half the vitamin C of lemons. And so we would probably expect that this is sort of, a different treatment instrument. As we've talked about, if we had different measurements in each of the two studies, right, where one measured any scurvy symptoms and one hypothetical experiment measured only the incidence of bloody gums, right, then we would probably expect these to be, it would probably argue these are not harmonized. Okay. So now we'll sort of add this piece of external validity. So this is our formalization of external validity. And we will say that a mechanism has external validity when we move from one setting to a different setting, if for every measurement strategy and almost every contrast, we observe the same treatment effect when we hold constant the measurement strategy and the contrast in the two places. And so basically the sort of non-technical summary here is that a mechanism is going to have external validity if it produces the same effect in two different settings where we have otherwise identical experimental conditions. So we do the same experiment in two places, we get the same result, right, on the units for which the mechanism should be active. That is how we're defining external validity. Okay. So pulling this all together, what can we learn about meta-analysis more broadly? So first, our goal is to try to understand when meta-studies are constituent comparable. So we're going to impose these two assumptions that I've told you about, both divergent validity of the measures within studies and external validity of the mechanism across studies. And by doing this, it's going to allow us to ask, when are the treatment effects produced by an externally valid mechanism comparable? And by extension, what quantity are we estimating in a meta-analysis setting? So result 1 is sort of given contrast harmonization. So let's first assume that for two experiments, they're contrast harmonized, so control and treatment are the same in both studies. The mechanism is externally valid and the measures are exhibit divergent validity in each site. So here we would say that the two experiments are comparable if and only if they are measurement harmonized, right? And the intuition here is pretty simple, right? So if we have two contrast harmonized studies that are comparable, so they're producing the same treatment effect, either they're using the same measurement strategies, right? Or we have two measurement strategies produce the same treatment effect, right? Which would be a contradiction of divergent validity. One site's using measure A, one is using measure B. Both of those measures are producing the same effect. It's externally valid, and hence we have this contradiction. The second result is given measurement harmonization. So here we'll have the two experiments. Here we'll assume that they are measurement harmonized. So we're looking at the same outcomes in both places. External validity holds across sites and divergent validity holds for the measures. And here the experiments are going to be comparable if and only if they are contrast harmonized. This is a little bit slightly more involved result, but we can think about the intuition by thinking again about the Lind example. So suppose that he had treated scurvy with lemon and orange on a different ship and lemon and orange on this ship, right? Which have different levels of vitamin C. So how likely is it that the lemon and orange generated a comparable treatment effect to lime and orange? Well, limes contain about half the vitamin C than lemons. And so we're effectively asking, what is the likelihood that oranges on the lime time should precisely offset this difference in vitamin C intake. And sort of, we find it, it's exceedingly unlikely. And that's sort of the intuition for this result. So then we can think, when are meta studies then comparable? And we can just combine these two results and say that meta study is constituent comparable if we have external validity across sites, divergent validity within sites, measurement harmonization, and contrast harmonization. And sort of the implication here that I think is the important takeaway is that non-harmonized studies will not necessarily detect an externally valid mechanism, even when that substantive mechanism is present in all settings comprising the meta-analysis. I don't have a lot of time. I'm going to think really quickly about how this fits into one framework for meta-analysis, but we can think about how it works much more broadly with other estimators. And so we can think about like what we're fundamentally doing in the meta-catas and sort of a lot of the other recent things is that we sort of take these reduced form treatment effects, and then we sort of look at sort of standard meta-analysis estimators, which are effectively structural, right? So we'll take the most simple for the purposes of this talk. So the fixed effects meta-analysis estimator simply says that we have a common effect in sites, and then we have some, idiosyncratic noise across sites, right? And so in the experimental context, right, we can think about this mu as simply being the treatment effect. And so in some sense, the actual assumption of the estimator is exactly in line with this idea of comparability. And sort of what we can think about then is that this structural parameter is sort of identifying this common treatment effect across studies. If each measurement strategy satisfies divergent validity, the mechanism is externally valid, and all the sites are both contrast and measurement harmonized. So these sort of results from this theorem 3. So I think there's a lot more we can think about how this fits into many other types of meta-analysis estimators. But I think what my takeaway from this is sort of causal meta-analyses have often been viewed, at least or at least I came into this meta-cata process of viewing these as sort of a pretty agnostic way to accumulate knowledge. And, in addition to these sort of standard identification assumptions within sites, we sort of are actually making further assumptions when we're sort of claiming these are comparable and estimating them in this way. And so we can invoke additional, we're both invoking additional within site and between site assumptions. And, we should probably be thinking about harmonization in a little bit more rigorous terms than what we're doing in current research. And I think that there's some limits to the agnosticism of accumulation of evidence in meta studies. So there's many other ways sort of on the estimation front that we can sort of make a lot of progress forward here. But I think it's useful to think about how these map into these goals of accumulation of fairly agnostic or work, at least at the study level. So I'm happy to take any questions. Thank you so much.
Thank you, Tara. Does anyone want to jump in with a question? Don, would you like to go? Or that's just a clap. Thank you. James has a question. James, why don't you unmute yourself and go ahead?
Sure, thanks. Thanks, Tara. I think this is it's really interesting, and I think it's an important direction to just highlight some of the the concerns that so I do a lot of meta-analysis.
Yeah.
And so the concerns that the assumptions that meta-analysts often just take for granted. But I'm wondering, so I guess where I'm stuck is how you would actually go about defining what is an identical contrast and what is an identical measurement strategy. It seems to me that like there's judgment about fit between operationalization and constructs that's unavoidable. Like there's no such thing as two identical measurement procedures.
Yeah.
So how do you deal with that? Like, is there any way to get around that at all, or are we just should we just stop ever averaging things together if they're not precise replications?
So I think I think that you're absolutely right, and this is sort of one of the inherent tensions here. So I guess I have sort of two responses to this. I mean, first, I think that I agree that there is sort of probably no such thing as an absolutely identical experiment or in terms of contrast or measurement strategies. I think that we can work to come a lot closer than we are. Right. So I think that often these things are taken for granted. We have, sort of the best case scenario. Some of the better case scenarios are, we've tried to harmonize one piece of this, and even within that, there's debate as to how well harmonized that is. But I think in terms of the contrast, thinking of both pieces, I think in terms of the measurement thing, we need to do a lot more research in terms of actually just defining thinking about what a comparable measure would be in different settings. So these metaketas are in many different countries. So is it, the same survey question up to translation? Is it sort of trying to harmonize on the the concept or construct and then sort of doing locally appropriate measures? So I think that there's a lot of work to be done in terms of trying to define what is closer and what is further. But I think also when you go across literatures, at least in political science, where this has been done, like there are certainly places that we would argue are much closer than others, right? In terms of how closely aligned both the measurement strategies and the contrasts are. So my favorite example in political science, as sort of where I think the harmonization is the tightest, is this like Kopic et al. Study of, campaign ads over time, right? Where the ad is changing, but sort of the research design and the measurement strategy is not, at least relative to the candidate that they track through sort of the course of an election. So I find that to be sort of the closest, and to the extent that we can identify sort of, closer versus further in the existing literature, I think it is productive to try to pull it, towards something closer, or at least try to model that variation if we can't harmonize things precisely.
Thanks again, Tara. I think
Thanks.
we're just at time at this point.